we go back to something called coordinate proofs. And coordinate proofs are just being able to show that a relationship is true. So for example, like if you're looking at an isosceles triangle, that the sides of the legs are congruent to each other using the coordinate plane, the XY axis, superimposing the figure that you guys want on it, and then assigning variables to it, and then proving it through algebraic relationships. So what we're going to do first is just practice that part of it, not the proof part, but just how do I assign variables and values, coordinate points to the vertices of a triangle that I have positioned in the first quadrant, or maybe in the first and the second quadrant. So here are some tips on the top that I would recommend that we do. Okay, if the figure is not given to you, we try to use the origin as much as possible. Either if I'm drawing a picture of a triangle, remember the pointy corners are the vertices or the vertex. If we're talking about singular, we try to position it so that the origin has the vertex on it. Or so in picture 1 and 2, you guys have the vertices are on the origin. Or if not on the origin, then it's one of the sides of the triangles is perfectly positioned, so it's like halfway in the first quadrant, halfway in the second quadrant. Okay, the other thing is for step 3, it says keep the figure as much as possible in the first quadrant. So many of the pictures that we draw will be in the first quadrant. Sometimes we'll utilize the fact that there's symmetry going across first and second quadrant to position it there. And we want to make sure we use coordinates that make computations as simple as possible. I'll explain what that means. It means that eventually it'll make more sense when we go over an example with fractions, but it means that if you know you have to perform a computation where you have to divide by 2, I would much rather divide an even number by 2 than an odd number. So assigning the variables such that it makes the computations that you're anticipating easier. Okay, so let's take a look at question 1. And all we're doing with question 1 is assigning a variable. So what you guys see is 3 coordinate points for the vertices, and what they want you guys to do is figure out that question mark. Okay, so assuming that this is true, and I'll walk you guys through the first one. Assuming that A falls on the origin, B has a coordinate point of 2p, 0, knowing that if it's an isosceles triangle, this is the vertex angle, that the vertex angle always is like above the midpoint of your base. Okay, it's always above the midpoint of your base. So according to this picture, we know that the length of AB, or how many units I moved over to the right, is 2p units long. So this is equal to 2p. Okay, knowing that, and if you can switch over to private chat for this one, but Christian just shared the correct answer to everyone. If you guys can just make sure it's private chat. What coordinate point do you think this X value for C is? And yes, if it's 2p long and then that's directly above the midpoint, then this must be P. Okay, so we just work with generalizing everything instead of trying to make things complicated. And so here is an example of where step 4, where they say try to assign the variable. So if you had to give this variable, if you assigned it yourself, the reason why they picked 2p is knowing that this coordinate point is directly above halfway, we would rather much take half of 2p than half of p. Let's say that you assigned this yourself and you called that p. Well, this would just be p over 2. So it's whatever you guys want to call it. You just base it off of what you initially stated. And for us, it was given to us that this was 2p. So we use it based off of that. Now, the reason why they assign q here, okay, when we think of an isosceles triangle, you guys don't have to draw this out, but an isosceles triangle just means that the base is the bottom, but that these sides are equal. So we actually don't know the relationship between the sides of the legs of the triangle versus, like, basically, we don't know how far up to go for y. So we assigned, or they assigned a different variable for that. It's not related to p in any way. Whereas this coordinate point right here did have a relationship with the pre-existing variable p. Okay, but again, the reason why they assign q is we don't know how far up this vertex falls. Okay, so let's take a look at 2. So once again, you guys have R is marked at the origin. This is an isosceles. I noticed that because of these markers right here. an isosceles right triangle. And they want us to figure out this time what the coordinate point for t is, knowing that you guys have moved over 2a units for x. What do you guys think? What's the coordinate point for t in this problem? Okay, good for the people who've typed it in so far. Okay, and we want to consider, okay, we've moved 2a units over. What did we go up? So the x coordinate is correct. Many of you guys have 2a. The y coordinate, some people put 0. But when you're thinking about where this coordinate point is, what is the y value for that one? These lengths are equal to each other. So this length is 2a. This also must be 2a. So we ran 2a and then we rose 2a here. So the coordinate point for the y also happens to be 2a. Okay, and you know, so there are some people that wrote like 2. We don't know the actual units, so it's not usually going to be like just 2 without a variable. It's going to have a variable tied to it. Again, because we don't technically know what the value of a is. It could be any length. It could be 4. It could be 5. So we want to make sure it's based off of previously assigned variables. Okay, so 3 is different in that your vertex isn't on the origin. This time it's still an isosceles triangle. So we know this time they put the origin as the middle, like kind of the midpoint between E and G. They did define what the variable is for the x coordinate for G to be 2G, 0. And then they defined up above here that the y value, again, we don't know how high this goes, so they assigned a different variable to it. They called it b. What do you guys think the coordinate point is for f here? What's the x coordinate for f? What's the x coordinate for f? And you guys want to consider like, well, what is the x coordinate of any point that falls on the, what's the coordinate point for any point that falls on the y-axis, right? So correct, right? Any point that falls on the y-axis has a x coordinate of 0. It's 0, something. So in this case, for our something, it's a b value because we're saying that this is b units high. We technically don't know how high it is, and it has no relationship with the g. So they assigned a different variable for it. Okay, now knowing what we know about f and g, what do you guys think the unit, what is the coordinate point for e? Good. Okay, so if we moved right 2g units, what is the coordinate points for? Okay, very nice. So this coordinate point is the same units away from the origin, but in the opposite direction in the second quadrant. That's -2g, 0. Very nice. Okay, so those are some of the beginning problems of coordinate proofs is given certain vertices already labeled, pre-assigned, you guys assigning the remaining ones. Okay, here are a few where we now have to draw it ourselves, assign the variables ourselves. Okay, so it says position and label each triangle on the coordinate plane. Notice that 4 and 5 only show the first quadrant, whereas 6 shows both quadrants. So we're going to always try to be on the first quadrant. In this case, they describe an isosceles right triangle, sorry, not right triangle, but just isosceles triangle, triangle RST, with a base of 4a units long. So when I'm looking at an isosceles triangle, just so that you guys remember what the base is, remember when you have an isosceles triangle, this is considered the base of the triangle, and these are the base angles of the triangle. Okay, because they defined it to be 4a units long, I'm going to want to put the base somewhere on an axis. So let's go ahead and put that on the x-axis. So we're going to put that this is the base and this is 4a units long. And they said they described the base as RS. So let's label this R, let's label this S. And T, because this is an isosceles triangle, the other two sides are going to be the legs that are congruent to each other. So let's position this so it's halfway above the midpoint. And let's sketch in isosceles triangle. And we know that these two are congruent to each other. The base is 4a units long, and the missing vertex is T. Okay, so What is the coordinate point for R, you guys? What's the coordinate point for R? Okay, we should always try to have a vertex at the origin. So this is 0, 0. Okay, so if the length of the base is 4a, what is the coordinate point for S? What's the coordinate point for S? Good, you guys are on the x-axis, so the y-coordinate should be 0, so 4a comma 0. Good. Okay, knowing that this is an isosceles right triangle, knowing that T is directly above the midpoint, now I want you guys to, and again, remember with the isosceles triangle, we have to assign all the variables now, but technically we don't know if the triangle is this tall or this tall or this tall, and I'm sure yours is slightly different from mine. So because that unit is unknown, that y unit is unknown, we're gonna pick a secondary variable for the y because we technically don't know how far up to go. So we're gonna call that b. Okay, so what is the coordinate point for, what's the x coordinate now? Okay, perfect, you guys. Halfway to 4a is 2a. Okay, and so, you know, and again, if I know that that's something I'm going to have to take a half of, I'm probably not going to want to define this as a, because then this would be just a over 2. But again, it's not wrong. It's just your comfort level with fractions and what you want to do to assign. I knew to draw this on the base here because they define the length of it as 4a. So it's easy for me to redefine these variables or these coordinate point variables using the fact that this is 4a, wanting that to fall on the x-axis or the y-axis. Okay, so the next question is isosceles right triangle. And so where you put the right angle, it's going to depend on the way that the question is phrased. But in this case, they said isosceles right triangle with legs of e units long. So it makes sense to me that maybe I want this to be that the right angle falls right at the origin. And the reason being, if this is an isosceles right triangle, when I sketch it, and this is a isosceles right triangle, that did not come out really nice, then the legs that I know are congruent happen to fall on the x and y axis. And that's nice because now it's going to allow me to define these points using the fact that each one of the legs is e units long. Okay, so it didn't define for me what needs to be the base or what variable vertices go with what variable. So I'm just going to call it DEF. And had you called it differently, that would have been fine because they weren't specific about it. Okay, so knowing that, I'm going to skip over the fact that we all know the origin is 0, 0 for E. What's the coordinate point for F? What's the coordinate point for F? Okay, so for F, since that is on the x-axis, good, it's E comma 0. This is an isosceles right triangle. So what is D equal to, you guys? What is D equal to? Yep, 0 comma E. So just kind of getting used to figuring out where to put the coordinate, put the legs, put the base. And because this description gave me units of measure based off of the legs, I put the legs on the x and y axis. This one talked about the base, so I put the base on the x axis. So now this one kind of forces us to put the variables in certain spots. It says equilateral triangle, so all three sides are equal, with a vertex of 0 comma rad 3b and sides of 2b units long. So where does Q have to fall? Where does it have to fall? 0 comma radical 3b. Where do I have to put that coordinate point? At the top is what someone said on the y-axis, right? If you guys have 0 comma anything, that means it falls on the y-axis. So let's go ahead and draw that and say Q has to be 0 comma rad 3b. Okay, then from there, then that means that the equilateral triangle falls in the first and the second quadrant. All three sides are congruent to each other. And they gave us an additional piece of information. They said that the side lengths, all the sides, or 2b long. So this is also 2b long. So knowing that, I'm going to assign a variable e over on this side and I over on this side for triangle EQI. What is the coordinate point for I? What do you guys think the coordinate point for I is? If the whole side is 2b, what do you guys think the coordinate point is for just I? Okay, very good. And you guys are so many times in like later math classes that you have a situation like this where you have to assign variables like this. So it is super important that it makes sense to you guys how we get some of these values. But yeah, half of 2b is 1b. Oops. So it should be 1b comma 0. Can you guys also tell me what e is equal to? What's the coordinate point for e then? Okay, very good. We're still on the x-axis, so negative b comma 0. Nice job, period 5. You guys are doing really well with this. Okay, so now what I'd like you guys to do is go backwards here. This was page 6. We're going to actually only do one other big example. Sorry, went in the wrong direction. And then start 2, but I think we only have time really for this one. Okay, so question 1, first it gives you guys a description and then it breaks it down to given and prove. These proofs are going to look very different from what you guys are used to. And I think to me, it makes more sense. And this is why we use a lot of this. This is page 5. Yeah. Okay, so there is an extra example above that I'll let you guys read at your own discretion. We'll do one full example because of time together here. So we're supposed to prove, this is a lot of words, so don't get overwhelmed, they'll break it down for you. Prove that an isosceles right triangle. So we're going to think, okay, we have to draw a picture of an isosceles right triangle. The segment from the vertex of the right angle to the midpoint of the hypotenuse is perpendicular to the hypotenuse. So what we're given is an isosceles right triangle ABC. So let's go ahead and draw that in on the space that you guys have right there. Let's go ahead and draw that. Okay, since it's isosceles right triangle, and I already have in my mind the picture of the isosceles right triangle that we had over on the other page. And for that one, I put the right angle right here. And it was nice for me, if it's an isosceles right triangle, to know that the legs are congruent and they fall on the x and y axis. That seems like a good positioning of an isosceles right triangle. Okay, so we know that this is congruent to this, that's the right angle. And then I just try to, at first, before assigning variables, I try to just make sure things make sense. ABC is the right angle. So B must be the vertex, and where you put A and C doesn't matter. So ABC. M is the midpoint of AC. So label all the things that they give to you guys. So M is the midpoint of AC. So go ahead and put M here is the midpoint. They want me to prove segment BM is perpendicular to segment AC. So what I'm trying to prove is that this is perpendicular to this. Okay, so a couple of things with coordinate proofs. Okay, coordinate proofs rely on Algebra 1 stuff. So formulas that you guys know from earlier in this year or from Algebra 1. So what I'm going to do on the very top is, or actually over on this side is just so that we have the problem there as well, is write some of the formulas that you guys should know for this section as well from previous lessons that we've learned. We're going to talk about midpoint formula. If you guys are given, like, let's say 2 coordinate points, A, B, and C, D. If they ask you to find the midpoint of that, what you would do is take the 2 x's, add them together, right? The averages of the x is what we learned in our exploration, and then the averages of the y's, which is B plus D over 2. So average the x values and then average the y values, and that's my midpoint. Another important formula that we should have memorized is distance formula. Okay, and that one you guys used earlier in the chapter as well as throughout the entire course. We kept referencing this. Okay, change in x squared plus change in y squared. So these are formulas that you guys have to know. And then the last one that we're going to talk about is slope from Algebra 1. Okay, so the slope formula is m equals change in y over change in x. And so what are we doing here? We're going to take what we know about the formulas that we have here, apply it to the coordinates that we have here to prove that BM is perpendicular to AC. So let me kind of ask you guys that question. If I'm proving that BM is perpendicular to AC, what would I use to prove that that's true? So think Algebra 1, okay? What would you guys use to prove that that's true? Okay, would you guys use distance formula? Would you use midpoint formula? Would you use slope? Yeah, if I'm talking about two lines being perpendicular, what do I want to show about the slopes is true? What must be true about the slopes? If you guys are proving two lines are perpendicular to each other, think Algebra 1. Okay, very good. Opposites of each other and reciprocals of each other. Very good. So we want to show slopes as opposite reciprocals. So it might ask you guys to show things are parallel, in which case you guys show that the slopes are equal to each other. They might want you guys to show that it's an isosceles triangle. So showing that the distance between 2 points are equal to each other for the legs. So different things like that. But for this particular proof, we just want to show that the slopes are opposite reciprocals of each other. The problem is we have a slope formula, but no coordinate points. So now it's up to us to define the coordinate points. Okay, so just looking ahead, you guys, we're going to have to define a coordinate point for A, for B, C, and M. M happens to be, again, the midpoint of AC. When I think about the midpoint, I know that I'm going to have to take something and then divide it by 2. So I might want to assign variables that are easily divided by 2. So when I'm going now to assign the variables, first, we know that B is 0, 0. Okay, again, it wouldn't be incorrect. In fact, in my notes, I have C defined as A, comma 0. But because I know I have to divide it in half, I might want to think about assigning that first variable to be something that makes my later computations easier. So here I'm going to define it as 2A, comma 0. If this is an isosceles right triangle, you guys, what is the coordinate point for A? What's the coordinate point for A? Okay, 0, comma 2A. Very good. So it has to be the same. Okay, and then the question next is, if this is the midpoint, then we have to assign a variable for M. If you guys have 0 and 2A as the x coordinates, and you add 0 plus 2A, and then divide it by 2, what is the coordinate point for M? If you're finding the averages of those x values and then the averages of the y values, what's the coordinate point for M? Very good. A, comma A. It's halfway, right? So A, comma A. Again, 0 plus 2A is 2A divided by 2 is A. 2A plus 0 divided by 2 is A. So A, comma A. All right, now we have the picture, then we assign the variables, and then now we show that the slopes are opposite reciprocals. So what slope specifically? You guys want to show the slope of BM and then also the slope of AC. So look at the slope for BM first. Okay, so if you guys are finding the slope of BM, this is M, this is B. So we find change in Y over change in X. So A minus 0 over A minus 0. So we get A over A, which is just 1. Now, if you guys find the slope for AC, that means that you're finding the slope between 0 to A and 2A comma 0. So let's do change in Y first. Let's say you do 2A minus 0. You took this 2A minus this 0, and then put it over 0 minus 2A, right? Over the change in X. What's your slope, you guys, for AC? What's your slope for AC? Okay, are they opposite reciprocals of each other? Okay, yes, they are. So this is one way we generalized everything, and we're able to show that they're opposite reciprocals of each other. Okay, the reciprocal of 1 is 1, and then the opposite being opposite in signs. So how we would summarize this is, since the slopes of AC and BM are opposite reciprocals, our conclusion would be that BM is perpendicular to AC. Okay, we will not have time to finish the next one, but I do want us to get just the picture going for that. So in the next example, it's still the same figure, isosceles right triangle. Prove that the segments joining the midpoints of all the sides of a right triangle form another right triangle. So let's go ahead and do the picture, at least get the picture drawn here. So if you guys can sketch the same exact picture for me with a right triangle, isosceles right triangle. And again, the word midpoint makes me want to assign variables so that I can easily take the midpoint or divide by 2 on it. So I'm going to call it the same thing. Let's call it ABC. And even defining midpoints, knowing that I have to define the midpoint, I'm going to call these 2A, comma 0 and 0, comma 2A. So same exact coordinate points as above. It's similar scenario. But this problem here, when I read it again, it says, prove that the segments joining the midpoints of the sides. So as best as you guys can you visually find on your graph the midpoints of all of your sides and then connect them? So what they want me to prove is that the segments joining the midpoints of the sides of a right triangle also form a right triangle. Okay, so we want to show that that blue triangle is a right triangle. So we have to define all the coordinate points. So right now we have the coordinate points for A, B, and C. Now we need coordinate points for this triangle here. So we're going to call that X, Y, Z. Okay, so let's start with Z, you guys. What do you think the coordinate point is for Z? What's the coordinate point for Z if that's the midpoint? Okay, very good. A, comma 0 on that one. What do you guys think the coordinate point for X is if X is the midpoint of AB? What's the coordinate point for X? Very good. 0, comma A. And lastly, the midpoint of the hypotenuse is Y. What is the coordinate point for that? A, comma A. Very nice. And we're going to start off the next class with this, but in order for me to prove that this is a right triangle, I would have to show that this is a right angle. In order to show that it's a right angle, it's the similar